Hello and welcome to lesson 2 of week 1. In this lesson, we are going to look at arrays. My name is Mildred. Now, in the last lesson, we looked at algorithms and we saw how we can write an algorithm to solve a problem. We want to apply the same algorithm to seeing how we can work on arrays or how we can sort an array. Let's say that we have a list of numbers and these numbers contain duplicates like this. So we'll have this list of numbers that has some duplicates here. We want to write an algorithm that will help us create a function that will filter out duplicates from this list. Whenever you want to write an algorithm in a language, you want to think about what are the methods or functions. Are there any inbuilt modules that can be used to make this faster and more efficient? Are there inbuilt functions that you can use? We think about lists in Python and we just want to think about all sequence type as a whole. What we know about lists is that indexing starts at 0. We know that lists can contain any number of items. We know that lists can contain duplicates. Is there a sequence type that does not allow duplicates? Is there a way we can convert from this list to that sequence type and convert back to a list? So we want to ask ourselves this question and put them into the algorithm. So the first thing we know is that this is a list in Python and it is a sequence type that can be converted to other sequence types and converted back. One sequence type we have that works is the set. A set only allows unique item and we can use the set method to convert this list to a set. So the first thing we want to say is a set contains unique values, convert list to set to filter out duplicates, convert set back to list, sort the list. So you can see how easy it is to think about this in this way. So let's implement this. Let's say def remove duplicates like this, and we want to pass in an argument called array numbers. We want to say unique numbers is equal to set array numbers, right? And then we want to convert it back to the list. So unique numbers is equal to list unique numbers. So we can give this a different name, set unique numbers if you want, set unique numbers, okay? And then now we have the unique numbers back as a list. We want to sort now, so we can just say unique numbers dot sort, right? Then we return the unique numbers. So this is a short way of doing this, and let's test this to see. So we have this number variable, so we'll just pass it in and let's run this to see. It's sorted and we don't have duplicates. So you can see the way we can think about algorithms in different ways. We can look for what already exists in the language, what we know about it. That's the first step. If you write an algorithm, you want to check the language you are going to use. Does it have an inbuilt function or inbuilt module that makes this faster? Is there a way you can do this? Recursion better than looping through? Is it better to do it in a particular way than another way? And then we can use a time function, and I'll show you how to use time. If you have different ways, you can put in all of your different definition and then you can time it. So for instance, we have the time module in Python where we can come here to say import time. And then when we want to run this, we want to first of all start with the start time before we print this, right? So I'll say start time is equal to time.time. And then I want to remove duplicates. I'm not printing this time, I just want to calculate the time. Remove duplicate numbers like this, and then I'll put the end time. The end time is equal to time.time, okay? And then I will check the time that it took. So I'll say time taken is equal to end time minus start time, right? And then now you can print it took time taken seconds to execute the function. So you can do that again. If you have several functions, you do exactly the same thing and call the function, the new function here, and then you can print out what the time taken is. So it took these seconds to execute, and you know that it took a fraction of a time. But this is not the best way to look at the efficiency of an algorithm, and the reason is the programming language used to implement it, the compiler or interpreter, the amount of data this algorithm is working on, how the code is written, and the computer hardware and operating system of the programmer all influences this time. So what is the best way for looking at the runtime of an algorithm? We want to look at time complexity. Now, the analysis of an algorithm involves evaluating the performance of the algorithm and the programs. And efficiency is usually measured in terms of time and space. We're going to use the big O notation to describe the time complexity or the space complexity of our algorithms, and we're going to use it to describe the order of the growth of time or space in terms of the size of the input. So what we're going to consider mostly is the worst case scenario of the algorithm to find its time complexity in terms of that big O. And in the next lesson, we are going to start looking at this using the bubble sort algorithm. Thank you and see you in the next lesson.